With over 10 million cars on the road, South Korea's traffic congestion is a huge concern. But hope now lies in the country's revolutionary high-speed rail project. Of course, an engineering task of this magnitude requires a giant workforce. 7,000 workers per day, amounting to 2 million people a year, are needed to make high-speed transport a reality. Despite the scale and cost, the ambitious plans get the go-ahead. The ultimate goal? To connect Seoul to the port city Busan, some 412 kilometers away. Very quickly, the engineers identify their first challenge: to tackle the rivers and valleys that stand in the train's way. In order for a high-speed train to reach maximum speeds, it needs to run in a straight line. But running straight in South Korea's mountainous landscape means going through them. 32% of the entire rail network will require tunnels. Rail engineers have to dig a route through its mountains to the port city Busan. But that's easier said than done. Korea's peaks are made from the toughest rocks on Earth, granite. To dig tunnels through barriers this strong in a conventional way would be near impossible. So engineers take a more direct approach. They blast their way through it. To complete one tunnel, they will have to use the combined power of blasting and drilling in order to defeat the granite. The success of this entire operation is the responsibility of one man. Project manager Yoon is the drill master of this march into the mountains.
More than 70% in Korea is mountain. So in order to build such a very directional high-speed rail system, you cannot but face it. There's so many tunnels.
To do this, Mr. Yoon has several weapons at his disposal. Meet Jumbo, a $1.5 million mammoth drill. Jumbo needs to drill more than 130 40-centimeter holes. As each hole has to be filled with explosives, it's vital they are drilled precisely in the right position to create the perfect blast. The explosions are also coordinated precisely so that an even layer of rock is removed across the entire blast surface. Now, Jumbo's tag team partner, the charging car, takes over. It's bringing a different kind of ammunition to the game plan. After each controlled explosion, the blast face has to be flattened before drilling can begin again.
If we didn't shoot the shockwave right now, then the rock surface can be moved. This very dangerous condition can be made.
The newly exposed rock is now weakened after the blast. It literally has to be glued into place with a blast of liquid concrete. And here's where the charging car comes in. This process is called shotcreting. As the name implies, concrete is shot out at extremely high pressures, filling up cracks and securing the loose bedrock. This synchronized operation takes place on both sides of the tunnel. Besides crushing granite barriers, rail engineers also have to make sure that opposing tunnels will meet in the middle. Because teams can't actually see where they're going, they need a little help from a higher power to ensure they're heading in the right direction.
Even 1 millimeter difference can make different tunnels.
To make sure the tunnels join up, GPS, or the Global Positioning System, helps map out the exact route to a centimeter via satellites 20,000 kilometers above the Earth and conveyed to receivers on either end of the tunnel. The eyes in the sky turn complex tunneling work into a simple equation. Despite all the care and precision, things don't always go according to plan. The engineers make a startling discovery.
터널 중심으로 주위에 Different ores were mined at a river surrounding the tunnel, so the problem of the tunnel stability was raised. We thought we could solve the problem technically, but the high-speed rail is being designed to be safe for 100 to 200 years.
While their high-tech machines sit dormant in the tunnel, the team has to deliberate on whether to push on with the tunnel. In theory, the tunnel can be completed, but there's no way of knowing how weakened the mountain has become because of the mining activity. It's a dangerous gamble. Structural weakness in either the tunnel or the mountain could mean life or death for train commuters. With safety a #1 priority, the team makes the difficult decision. The tunnel has to be shut down. A new one has to be built, and the nearest suitable location is 6 kilometers away from the original site. A minor detour for the train, but a major setback for the team. So it's back to work on a new tunnel, just one of over 50 that must be built during the course of this project. The tunnelers have another challenge. The KTX train is heavier than the Eiffel Tower and longer than 4 football fields. Tunnel sizes on the line have to be enlarged to a generous 107 square meters to accommodate the train. The new tunnels dwarf Germany's 82 square meter and France's 62 square meter designs. But enlarging the tunnels also sets up the next challenge. When you've got 700 tons of metal hurtling at 300 kilometers per hour through an enclosed space like a tunnel, things can get noisy.
When the train comes and approaches the entrance of the portal, then the airs can be compacted through the tunnels.
With so much pressure building up, there's only one way the air can escape, and it does so just like a bullet leaving the barrel of a gun.
And just after the tunnels, there are big noise, bang!
The resulting sonic boom can be heard and felt for miles around.
Air transferred vibration, all the windows and any other things, every time shake. There's a big problem and very complaint from the neighbors. Big problem.
To solve this potential problem, the Koreans decide to design their tunnel mouths in the shape of a bell.
The edge part is like this. This is the edge of the bell. This is a special design because of the reduction of the air pressure.
As the train exits, the bell mouth disperses air upwards and outwards away from the train, therefore reducing high pressures built up within the tunnel. The design helps reduce noise and vibration by more than 30%.